What is quantum error mitigation in computing? Have you ever wondered how quantum computers deal with errors? Quantum error mitigation is a fascinating area that addresses this very question. In the world of quantum computing, errors can arise from various sources, making it essential to find ways to manage them effectively. Unlike traditional computers, quantum computers use quantum bits, also known as qubits. These qubits can exist in multiple states at once, thanks to a property called superposition. This unique feature allows quantum computers to tackle complex problems much faster than their classical counterparts. However, qubits are incredibly sensitive to their surroundings. Factors like thermal fluctuations, electromagnetic interference, and even tiny vibrations can introduce noise that disrupts their delicate states. This noise leads to errors such as decoherence and gate errors, which can distort the results of quantum computations. That's where quantum error mitigation comes into play. The goal of quantum error mitigation is to enhance the accuracy of quantum computations by minimizing the impact of these errors on the final output. This is achieved by running multiple versions of a quantum circuit and analyzing their outputs to estimate a more accurate result. Unlike quantum error correction, which actively detects and fixes errors using additional qubits and complex encoding schemes, error mitigation works with the existing noisy quantum hardware. This makes it a more practical approach for current quantum devices, which often have limited qubit counts. There are several techniques used in quantum error mitigation. One common method is zero-noise extrapolation. This technique involves intentionally increasing noise levels and then extrapolating back to estimate what the result would be without noise. Another method is probabilistic error cancellation, which employs statistical methods to cancel out errors. Symmetry verification is also used, checking for consistency in quantum states to identify and reduce errors. Quantum error mitigation is vital because current quantum hardware is not yet capable of full fault-tolerant quantum error correction due to physical and engineering limitations. By reducing the effects of noise, error mitigation helps produce more reliable outputs from imperfect quantum systems. This is essential for enabling practical applications of quantum computing today. However, quantum error mitigation does face challenges. These include scaling to larger quantum systems, accurately characterizing noise, and managing the computational overhead of mitigation techniques. Despite these hurdles, quantum error mitigation represents a significant step toward making quantum computing usable in real-world scenarios. It helps bridge the gap between noisy quantum hardware and the ultimate goal of fault-tolerant quantum computation. This allows researchers and developers to extract meaningful results from current quantum processors while full error correction methods continue to develop.